Today we are going to learn about the science of chromatography. In this technique, we will learn about the different method of separation of a mixture of a compound. Why the chromatography is so important is that the chromatography is a technique through which we separate the mixture of a compound into individual compounds. The individual compound has gotten a different properties and which can be evaluated on their individual prospect. So with this regard, this unit of absorption chromatography methodology, advantage and disadvantages contains 4 different chapters which includes paper chromatography, column chromatography, TLC and electrophoresis. In this unit we will see about all the chapter individually, but here we are going to learn about the absorption chromatography. If you look into the science of absorption chromatography, it is the oldest technique through which the separation of compound were attended. So I mean, this was the very first that the plant pigment were separated into different component by sweat, and it was given a regard for the chromatography science. So let us see what happened in absorption chromatography. Before we go into the absorption chromatography, let us see about that. How does the absorption chromatography works? This is the oldest type of chromatographic technique. It make use of mobile phase, which is either in a liquid or in a gaseous form. The mobile phase is absorbed onto the surface of a stationary solid phase. So the compound which has to be separated is placed onto the stationary phase, and it is flowed with a mobile phase which can be either a liquid or a gas. So when we use a combination of a stationary phase and mobile phase, the compound which has a mixture is getting separated into individual component, right? So what is the principle for separation? If you look into the principle for separation of absorption chromatography, the absorption chromatography involves the analytical separation of chemical mixture based on the interaction of absorbent and absorbent. The mixture of compound or a liquid gets separated when it passes over the absorbent bed that absorb different compound and different rates. So what happened basically in this, the compound which has to be separated is placed onto the stationary phase, and then it is embedded into the mobile phase, or the mobile phase is poured onto this. So what happened, based upon the affinity of the separated compound onto the stationary phase and in the mobile phase, the compound travel with a different speed. If the compound travel with a faster speed in mobile phase, yield fast, and if the compounds travels slowly into the mobile phase, is eluted later. Or it can be said something like this: the compound which spend more time onto the stationary phase elute at the last, and the compound which spend less time onto the stationary phase elute first. So what basically happen when we are doing the separation of a compound using this, right? So the compound, right, which is called stationary phase, basically is absorbent on which the compound make a intramolecular forces, right? And on this intramolecular forces, the compound is getting absorbed onto the stationary phase, and the compound to be separated spend time between the mobile phase and stationary phase, and they attain equilibrium. When the equilibrium is being attended between this and and looking into the nature of a compound, what happened, the compound spends more time onto the stationary phase, or less time into the mobile phase, or vice versa, it spend more time into the mobile phase and spend less time into the stationary phase, which make it to elute, right? So basically, what is absorbent, right? Absorbent is a class, is a substance that is porous in nature with high surface area to absorb the substance on its surface by intramolecular forces. And some of very commonly known absorbents are silica gel G, silica gel N, silica gel S, and hydrated silica gel silica, cellulose microcrystalline, alumina modified silica gel. So this basically, why do we have so many stationary phase? Is the reason is that each of these stationary phase has a different signs. They bind differently with the compound, right? Or the compound the compound present in a mixture of present the mixture of compound present as a sample, right? So when they bind on to this stationary phase, sometimes the binding interaction is so hard, or so strong that it doesn't elute out from the stationary phase. So looking on to the nature of the stationary phase, we choose it, right? We basically choose, or we modify in the existing stationary phase to choose as a absorbent for a particular compound to get under separation. And similarly in mobile phase, we do prepare a mobile phase, we do prepare the mobile phase that I mean, which is a proper mobile phase which has to be chosen. So look here is a pictorial aspect or explanation of the compound to be separated. So when you look at here, we have two compound X and Y which has to be separated here. So when we have to separate a compound and X and Y, what we have done before, we have loaded the sample into the column. So how to pack a column, we'll discuss this in the coming chapter of column chromatography. First, what we did, and we have a pack the column with a stationary phase, and choosing of a stationary phase again is a science, depending upon if you have an initial idea about the nature of your compound, or basically if you're a synthetic chemist, basically you can load a modified silica or silica of your choice, or a stationary phase of your choice, which is suitable for the separation of that particular compound. In spite, if you look for a separation of a compound which you possibly don't have an idea which type of compound it could be, it's a blind error study that you can choose any stationary phase and you can try and you can perform it. But the majority of time the silica is chosen, or the most preferred stationary phase is chosen, and then the sample is loaded, and then the sample travel with a different speed depending upon the nature of binding ability to the stationary phase. If it binds strongly to the stationary phase, it travels to the slower speed, right? So for an example, here we have shown X and Y, the two component to be separated. So X travels slower than the Y, and Y travel faster than the X. So X has got eluted first, and then the Y has eluted first, and X will be eluted later, because the X has got a more binding capacity to the stationary phase. So keeping in this mind, right, what we have to learn about that, there is a equilibrium attended between X and Y to get a separation, right? So the method is that you need to have a two phases called stationary phase and mobile phase. You have to choose the stationary phase looking upon the nature of your compound. Again, you have to choose the mobile phase looking into the nature of your compound, right? These two are not easy. These two signs are not easy. Choosing a stationary phase and choosing a mobile phase is trial error method, right? Which could be a trial and error method, which you can find out later on which of the stationary phase could be better for your study, which is the particular solvent could be better for the separation of compound, or which is called mobile phase. So look here, when we look into the mobile phase, what it could be either liquid or gas, which we will see into the coming classes about the liquid chromatography. But we are not going to do I mean going to learn about the gas chromatography in detail, because it is another unit, right? But where we learn about the liquid solid chromatography, which contains generally the column chromatography, and then the TLC, thin layer chromatography. So what are the apparatus? When you look into the apparatus which has to be used for the separation is chromatography jar, thin layer chromatography plate. Basically, a jar is needed where the plate has to be placed, or where the stationary phase has to be put into the column. Right? It's basically made up of a glass and with a cover with the lid. And what you need to be attended here is a equilibrium. Right? The science of equilibrium we will study when we are dealing with the paper chromatography or TLC. That why the chromatography jar should be covered, and why the equilibrium has to be maintained, right? And if you look into here, the plate of TLC is it of in different size, 20 by 20, 20 by 5, 20 by 10. This all because that how many sample you need to for separation, right? If your sample is high number, you need to have a 20 into 20 centimeter, because plotting will be easier. You should have a sufficient space between two sample to get it separated. If it's not, what happened, merging will take place, right? Which we will see when we talk about the paper chromatography in detail, and when we talk about the TLC in detail. 20 by 5 is needed when you have a one sample to separate, and 20 by 10 more than one sample, right? So it is all about the science. And the plate picking is again about idea how many sample you need to study for. And then again you have you need a capillary tube to plot a sample, right? The loading of a sample is again in adsorbent chromatography is a great science, right? You cannot simply load a sample, and you could not load too much sample, right? You need to change the the size of a column when you have a too much sample, or when you are loading too much sample into TLC, probably will lead you to the merging effect, right? So choosing all this depends upon that on your capacity of your sample, right? How many samples are there, how much quantity of a sample is there, right? So this all is a involvement when you do do a separation of a compound using absorption based chromatography. And then again, mobile phase you choose here is a liquid or a gas, and stationary phase again what you choose is depending upon what type compound you are going to see. So after this slide we will see the in the next slide we'll see about the other detail of the absorption chromatography. Till then, if you can understand this and there will be a question for this section, you can answer, and you can understand this how does the absorption this work, right? So for this, thank you so much.